Well, as you know, this session will be in English, okay? Now it's the time exactly, 10:30. So welcome to Drupal Strength Scaling. First of all, this is my first session in English, okay? Not my first session, but so please forgive me for any mistake that I might commit. I will start just presenting myself. I am Zequi vázquez. I'm from here, from Jerez. Well, this is a small resume for my career. I am a computer science engineer. I studied here in the University of Cádiz. And I have 2 masters, one of software engineering and another one on IT security. I finished it last year. And as a professional, I have more than 5 years of experience as a web developer, and 3 of them are fully using Drupal. Currently, I have specialized on DevOps, and currently I am freelance DevOps. I am available to work for some client if you need it. Also, I'm very interested in IT security, Linux, Python, and Node.js, which is a language that I discovered with this project. I will comment it. And I really like it. Not everything is computers in this life, so I always like to talk about my interest. I like rock and roll, you know, long hair and so. I play the electric guitar. I have my own rock band. I love video games. Also books, beer, whiskey, etc. And now that you know me a bit more than before, I will go a bit faster. This is the points, the index of the presentation, the contents. First, I will give a minor introduction about the talk itself. Then I will talk about the project. Yes, I forgot to say before, this talk is about a project in which I have been involved with the last year. This has been the result of 1 year of work with a wonderful team. And I will present the project here because the technologies that we have used, that technologies have less than 1 year. So, you know, it's very, very up to date. So, in the second point, I will review the project. On the third point, I will comment some problems that we found and the solutions that we take to tackle that problems. Then I will show a little demo if we had time, I hope so, and then some conclusions. Okay, so I will start with the introduction. And well, this is Drupal Strength Scaling. So, first of all, what is scaling? The concept itself is just the capacity of an IT system, a technical system, a computer system, to manage more users as they come to request the services. No? In that case, for Drupal, we're talking about web scaling. That means that no matter how many users come to ask for a page, the Drupal will be able to control and manage that requests and serve the responses. This is very related to performance, but it's not exactly performance. Performance is the ability of the system, performance is the ability to have a good speed. I mean, to serve the page fast and to not use the resources in a bad way. Scaling is the ability to be able to manage more users. In this case, there are 2 types of scaling, which is horizontal scaling. That means we have 1 web server and we add more servers. You know, so that's why it's scaled. You can imagine we add more servers, we have horizontal. And vertical scaling is we have 1 server, but that server grows in resources, more memory, more CPUs, etc. In this case, the technologies that I have used are related to horizontal scaling. Okay, we will see later. One point I want to talk about is that Drupal is highly highly cache dependent. That means that we do not have only to scale the web server itself, but the main cache and all the, the cache systems, because if we do not do that, we can find a bottleneck, and that's a problem. We want to scale all the application. Just a review, okay? Classically, to improve the Drupal scaling ability, we can use, performance, scalability, and availability. We can use main cache, APC, and OP cache in last versions, varnish to serve, the HTML faster for the anonymous users. To get availability, we can use redundancy, horizontal scaling, more servers. And there are a lot of modules for Drupal that improve the cache system. For example, Boost, Auth cache, etc. Just choose the one that you prefer. Another point which is important in this session is cloud computing. Cloud computing and distributed computing, okay, and containers, in this case, Docker. The main advantage of the cloud computing is the elastic computing. What does this mean? We can get automatic horizontal scaling. I mean, I receive a spike of users that want to render something on my Drupal, and the horizontal scaling just happens. And when the spike passes, the horizontal scales go down, so I don't consume resources that are not needed. In theory, all the providers of cloud computing, Amazon, Microsoft, Red Hat, etc., they say, hey, our CPDs are great, we are cool, and you have full scalability and full availability. Liars. That's not true, that's false. Why? Imagine that you use Amazon, which is my case, and Amazon has availability zones. There are different CPDs, okay, and if you use just one availability zones, you are in risk of that CPD go down. That happened to me in a demo, so that's not good. The solution I will talk about later, but it's very easy. It's just distribute your machines in several availability zones. And there are sorry, a bit nervous. There is a hidden enemy which the providers don't talk about it, and it's the budget. They sell you, solution, you have a lot of scalability, you have a lot of features, but they shut up about the budget. The problem is that if you don't control exactly the services that you request, your machines and everything, your budget will grow until infinity and beyond. You remember Toy Story? So, last point here, the containers, Docker. I have heard a lot of people talk about Docker as dev local and dev environments, but it's really Docker only for have an easy local environment? The answer is no. We will see later. Okay, so I will talk about the project. This is some of the requirements of the project. I will go a bit faster. Okay, we have Drupal 7 multi-site install. The old platform, it had about more than 30,000 of Drupal sites in a single Drupal installation, not multi-site. That database was crazy. And well, we need to scale in the next 2 years up to 100,000 sites. Crazy. Businessmen, which are not involved in technical details, they ask for, no, I want 100% availability. I don't want downtime. That's not possible, so the compromise is 99.999%. That means 8 hours a year. That's crazy too. Of course, high performance, lowest possible cost. We don't want to spend money. We need to control the site creation from an external app. Okay, we need to have the ability to just deploy a new site. Okay, a new client asks for, you have it easily. As a technical requirement, we want to reach the availability close to 99%. We need to make automated and not disruptive deployments. That means deployments, totally transparent deployments, so users don't get downtime when we deploy. We want to be able to execute Drush commands on all sites. Remember, 30,000 sites means 30,000 databases. Whoa. Of course, we want to migrate from the previous platform, and this is a good point. The development team, we were 3 people, apart from QA and managers and so. 1 front-ender, 1 back-ender, and 1 DevOps, who was me. So you can imagine my face when they told me this. What? This was crazy, you know. Are you seriously asking us to build this? So yes, it was a bit scary first, but thanks to the people involved in the project, well, we just relaxed. We are computer scientists, aren't we? We have the ability to explore new technologies and see if they fit the needs of the project. And we found the usual technologies were not enough. We cannot have an autoscaling group on Amazon with, let's say, 100 machines. No, it's not a good deal. So, what we look for? Open source. Open source is great. There are a lot of community power, that research a lot of apps, a lot of technologies, and we thank them. Because thanks to them, we have the tools to develop this project. In this case, you know, rock and roll, Stairway to Heaven, Led Zeppelin. In this case, we are going to the cloud. So we want a stairway to the cloud. We are using cloud computing, so we can we can use the advantage of the cloud computing very well. And you know, remember, Docker is more than Docker. So we are using Docker in production. I have heard some people to tell me, Docker is not ready. No, yes, Docker is ready for this. So desperate times becomes funny times. This is the technology stack that we use it in the center Drupal, the multi-site Drupal, and we use it Amazon Web Services as the cloud provider. This is Apache Mesos. Okay, it's a software that let us build a cluster. Marathon is an app which runs in the top of Mesos and let us use Docker containers, okay, inside the cluster. So we decided to use Nginx instead of Apache because, well, we needed a performance boost, and Nginx is more configurable than Apache. Well, maybe more easily. Node.js for the external app to control the sites. MongoDB for the fields tables on the databases. And Ansible to orchestrate the deployments. Ansible fits very well, works very well with Amazon Web Services. So I will review some details. First, we're going to see the Drupal over Nginx and PHP FPM, the web server itself. Well, Nginx, I have said, is very flexible. It's a bit hard to configure, to fine-tuning, but once you have reached a good settings, a good configuration, it's great. Also, you know, Nginx does not have PHP as a module of the web server itself, but Nginx have one process, and PHP FPM has, it works as an independent thread on the independent process. So that increases also the performance significantly. And again, you can fine-tuning this to get more performance and stability. So to identify the sites that are created, remember we're talking about thousands of them, We use DynamoDB, which is a NoSQL database on Amazon Web Services. So we use this to identify which sites exist in the system. You know, we have to manage a lot of databases, and we want to do it well, you know. And well, just a point, additional point. We integrated mod security, you know, intrusion detection system with custom rules for Drupal. Okay, I wrote a lot of them, and I think I will publish them when they are fine-tuned. It will be soon, okay, when I have some time. You will have news. So we have the web server here. You know, the Node.js app, which we are using to control the multi-site. It's just a Node.js app which uses the Amazon Web Services SDK, software development kit. Well, why Node.js? Why so asynchronous? Well, that's the reason. Asynchronous. We're talking about we need to just launch a site, but a new site, a new Drupal installation. We use it a profile, a custom profile. You know, a Drupal site install is not automatically done. It takes about 2 minutes, 3 minutes, it depends. So we want just to launch the process, the site creation process, and then forget about it and get notified when it's done. So we did it that way. Again, we use DynamoDB to store a list of deployed sites. This means, I will explain how this works. I, as a user who wants to create a new site, I access to the Node.js app, accessor was called, and I just ask to create a new site. The subdomain, the user, you know. Then the Node.js app launches the drush command on the web server, then forget about it, and when drush finishes, it notifies with the result, error or OK, to the Node.js app, and the Node.js app will store the state of the site on the DynamoDB table. So the web server can know which sites do exist and which sites just don't. And well, another detail we needed in this app, an API to allow batch operations. I mean, we need about 500 sites. Well, we use the API with a JSON REST API to be precise, and we have all those sites created. Okay, now I'm going down in the tech stack. Once we have the Drupal running over Nginx, we need to be aware of some details, which are, we need a stateless Drupal container. What does this mean? That means that the Docker container which have the web server, we don't want any data there. We only want the code and the web server configuration, you know. So the main cache nodes out of the container, the MySQL out, the MongoDB, and everything out. So the files directory, we also need it out of the container. We use S3, you know, Amazon S3, the simple storage system. And for main cache, we use Elastic Cache. You have there the schema. Main cache is Elastic Cache, a service from Amazon, RDS for the MySQL. For MongoDB, we do not use DynamoDB, but Mongo MMS, which is a feature which the people who created Mongo have, which let us to just create instances inside of Amazon with a replica set of MongoDB system ready to be used. So S3 and DynamoDB for the list of sites, remember. And additionally, the emails, we don't want the emails to be managed inside the container, so we use Postmark to send emails. We do not receive emails in this system. Well, as an additional point, we use New Relic to monitorize. We just use the PHP 5 New Relic extension, and I recommend you. It's a very good tool to monitorize systems. 20 minutes, okay. Well, the cluster itself. These are the technologies will let us have our scale ability to go extreme. Okay, we use Apache Mesos and Marathon. Mesos is a cluster software. You know, we can have like 10 nodes, 10 machines, or 1,000 machines. But installing Apache Mesos, we can have 1,000 machines that behaves like one machine. I mean, one machine with the number of CPUs being a zoom, you know, a sum. The number of CPUs are just a sum of all the CPUs available on the cluster, and the memory also gets you know, assume. We can have, so sorry. You know, a cluster, how it works. We can have a single machine or something that behaves like a single machine with a lot of CPUs and a lot of memory. The hard disks are not behaving this way. Okay, the hard disks are independent, but well, that's no problem for us. So, in Mesos, we have two kinds of nodes. We have master nodes, and which orchestrate the workers. Okay. In this case, we use Zookeeper to you know, promote the master. Let's suppose this is the main master. So if it goes down for some reason, Zookeeper will promote this second one and will launch an alert to tell us that the first master go down, so that requires our attention. And well, in the top of the cluster, of the Mesos cluster, we can have a lot of applications. Okay, there are like 100, if I don't remember, but in this case we are interested on Marathon. Oh yes, the group of applications that work with on the top of Mesos are called Mesosphere, if I don't remember, but okay, you can look for it. The code, this is all open source, and the code is available on GitHub. So we want to focus on Marathon, which let us launch Docker containers in the top of the cluster, and Kronos allows us to run cron jobs. You know, inside of a Docker container, cron jobs do not work, so we need this application. It works very well. And Marathon gives us a REST API to manage the containers, the Docker containers, and the apps that are currently running. Okay, we'll explain now why I have a main worker and a group of workers. This is the schema, the full schema of the system infrastructure. Okay, we have okay, as I was saying, we are working on the top of Amazon Web Services, so we have each one of the squares are EC2 instances. Okay, we have two masters, one main worker, and an auto-scaling group of workers. So the route 53, you know, the DNS points to the auto-scaling group, to the workers. And how this works. When we receive a large load of users asking for our system to serve more HTML, we want more content, it's easy. The auto-scaling group just acts and creates a new EC2 instance, so we have another server on our cluster, and automatically 2 extra Docker containers with the server, the web server, just get deployed in less than 30 seconds. So you can imagine if a big spike of workload happens, we are ready to manage that. Users basically just they are not aware of this happening. When the spike passes, then that EC2 instance gets killed, and we are saving some money. So here are the servers, the external services, you know, and MongoDB we use MMS, you know, the managed system on EC2 instances. Basically, this is the architecture, okay? And additionally, I have to say we use Varnish and Node.js. We use the main worker to have the Varnish container with 10 gigabytes of RAM. We only save on cache the HTML, no CSS, no JS. No, we don't need to save that because that is saved on S3, so we don't have to look for that. And the Node.js app, we only want one container, so it's also on main worker. And the question is why? You know, when an auto-scaling group grows up, it doesn't matter. It creates the new EC2 instances, and then the containers are deployed, and we're okay. But when auto-scaling group kills an EC2 instance because we need to scale down, if we had the Node.js and Varnish containers inside, we have a possibility that the node with the Varnish and Node.js container gets killed, and then we have like a couple of minutes until the cluster just reconfigure and show it. And that's downtime. We don't want downtime each time we have a spike, so that's the solution. That's it.
Excuse me. How did you bear with the high availability of the main container?
The main worker. We have it redundant.
Failover.
Yep. I just forgot to, add more. Okay. So we're talking about the deployments. Lazy DevOps is best DevOps. I prefer to code something once and then just, hey, we need the same code again. I can go for a beer. I don't have to worry about this because it's done. In that case, to manage the environment, an Amazon Web Services environment, I recommend you Ansible. Ansible is very simple. I think about Ansible as Bash with steroids, but it's very powerful because it's like execute Bash with steroids, but in all the servers that you need at once. So it's simultaneous. It's the cloud modules for Ansible are amazing, very good. And this is a trick for the containers. I do not use only Dockerfile. I use also Makefile. Okay, this is over 9,000. Powerful. Why? When my developers need a local environment, they just need to clone the Git repository and execute make local. They have a local environment. And when I have to make a deployment, I update my GitHub branch and execute make deploy. That's it. And remember, no downtime. Thanks for Makefile and thanks for Ansible. So, a single command to create and destroy environments. 2 years ago, I just would not believe if someone tells me that, but it's great. So, additional stuff, and I finished describing the project as I think, whoa, I need to go faster. Okay, Amazon Web Service do the backups. So, okay, that's great, but do not trust on the default settings. Okay, you have to configure it, fine-tune it. We have a firewall for the internal subnet and the external subnet. That's called security groups. Very simple. It's a firewall, and it's a firewall. That's not more. Remember to use protection kits. So we have a lot of REST APIs. So please, HTTP auth. We use it for all of them. Log centralization is very important because if we have thousands of servers, in an extreme case, we want to have one point to collect all the logs. If not, that will be crazy. So Mesos, Apache Mesos, will let us have all those logs in one place. I will show you on the demo if it just works, and if we have time, I will go faster, okay? And okay, everything that I have said in this slide, it does not matter if we do not have a recovery plan. If we have a disaster, we need to have a plan, automate it if possible, to just get the service up and running. Remember, 8 hours of downtime a year. So, problems and solutions. I will talk about some details. We're talking about thousands of databases. You know, this is crazy. One site is one database. 100,000 sites are 100,000 databases. You know that we cannot manage it that easily if it's split. So let's do low level. MySQL uses one folder per database which is created, and inside that folder we have one file per table. If I don't remember, but it's in NodeDB. I don't remember well, but it works that way. And on MongoDB we have a similar problem. When we create a database, empty database with one empty collection on MongoDB, it allocates 600 megabytes for an empty database. It grows that way. I mean, when we reach the 600 megabytes, then it will create another block and another block, even if it's empty space. So if we create just one database for a lot of sites, that will grow. Is exponential, you know. First we have 600 megabytes, then 1 gigabyte, then 2 gigabytes, etc. Conclusion, this is not manageable. This is crazy. This is hell. Sorry for that word. So, solution, divide and conquer. Very easy, you know. I will explain very fast. We just identify each site with a hash. We use the subdomain. You know, we have Zequi dot blah 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 blah. You know, the full domain. So I get that Zequi in this case, and I use a hash. I don't remember if it's MD5 or SHA-1. One of them. We only want a hash to just be able to extend. SHA-1, I think is. So we use that hash to prefix all the tables on MySQL, you know, on database array on settings PHP, and for MongoDB we had to hack the module to allow the prefixing. It's I have to upload or try to upload the patch. So we have each site identified with a prefix, which is very easily calculated, you know, from the subdomain. So we want to group 500 sites on one database, and the tables are not having conflict because of the prefixes, both MongoDB and MySQL. Which are the numbers? MongoDB, in using this 500 number, the maximum size for database is almost 4 gigabytes, which is manageable. And for MySQL, the number of tables for 500 sites. Remember, field tables are on MongoDB. So MySQL, each site has, I don't remember if 96 or 98 tables. So we have for 500 sites, 62,000 tables in a single database, which is actually very manageable. You know, that discards the low-level work because it's crazy. But we have done a bit. So, the way of a request, like the way of a summary. What happens on the settings PHP when we receive a request to identify the database? Well, we just, on first time, we receive an HTTP request, and we identify the site, the subdomain. We calculate the hash and we ask on DynamoDB, hey, which database number, 0, 1, 2, 3, etc., it's this site, 3, for example, okay? We identify the domain from the request, as I have said, calculate and then ask. And then we have the prefix, okay? It's very easy. And that happens for all sites, so we use it memcache, so the DynamoDB request only happens once. Then it gets cached on memcache, so it flies. You know, it's better than it sounds. And well, just to comment a silly error, because it's almost stupid, we found that the site creation process, you know, we launched from the Node.js app, we launched the site creation process, and we had a timeout. 50 seconds. We review very deeply the PHP FPN configuration, the Nginx configuration, and well, we fine-tune it very, very deeply, okay? So, but it just still happens. You know, we were very under heavy pressure, so we just didn't have time to think clearly. So the solution, fire and forget. I just launch the site creation process, and when Drush finishes, it will notify me. So I don't have to worry about that timeout. It worked very fine, but further investigation, when all passes, all pass it, you know, all the pressure, the timeout was produced on a proxy. Shame on me. So other problems found. Well, I will go a bit faster. Okay, we had instability and autoscaling group. It was caused because of the, you know, the main worker being deleted, you know, when the autoscaling group scaled down. That's because we just get those Varnish and Node.js containers out of the autoscaling group. The MongoDB ran out of space when in the middle of the migration, so you can imagine my face when my chief told me the migration is not working. My face was, what? Again. So one more advice. If you use PHP FPN, just disable slow log. That was causing a lot of problems. You know, we can't have more than 100 S3 buckets on a single account, so on the version 2.2, if I don't remember, but of S3FS Drupal module, we can configure the one bucket and one subdirectory on the bucket for a site. So very easy. We use the hash, and we have the bucket, one bucket for all the project, and one directory on the bucket for each site. You know, the remote and massive Drush. We need to be able to execute Drush on all the sites. So I create an API to just receive the question. So, well, we made a migration, and you know, RDS. The bigger that gets the size of the instance, the faster that it goes. Okay, I will do a demo, a very fast demo. Okay, please do not pull your arms out of the window because my demos are very, very dangerous. It's a video. Thanks, Niederman, for the advice. Okay, this will be fast. Okay, I understand that you don't see many things. This is Mesos, okay, and this is my console. On Mesos main board, you can see here the summary of resources. We have the number of CPUs, the memory. Those are a list of containers that are killed. The active task is a list of the running containers. Well, you can see we can access a centralized logs. On the top of Slaves, we can see log. I will publish the video after the session, so you can see it. And well, here the hardware resources. In this case, we don't have any containers, so the CPU and the memory are idle. They are not being used. So I will get an advance. Okay. Well, let's see it. Okay, there, when a container gets killed, that way we can get each container, we can access to the sandbox of the container. We can access the std out, the standard output, and the standard error output. My makefile on the containers are a bit modified, a bit customized. So I have all the logs of the system on that sandbox, and all the sandboxes are reunited on one shared folder. So we can see here the active frameworks. We can see Marathon and Chronos. Remember, Marathon for Docker containers and Chronos for the Chrome jobs. I will pass the video, okay? You can see it later. I don't want, oh, that's the the Marathon interface. We have no running apps. The demo, the video itself will tell you, will show you, sorry, how to deploy a container and how to manage the application of various containers. I will show you, this is the Chronos interface, okay? Very easy to create the Chrome jobs. You can see which app do you want to be triggered, when, and permissions and so on. The time, okay, 5 minutes. I will try to, okay, I will show you very faster here. Come on. Okay, here. It's a JSON file, you will see. Basically, I say to deploy a Docker container. We use the image. We use Docker Hub, a private Docker Hub to upload. I mean, when I update my local branch of Jihad, then I create a Docker image and I commit the Docker image. Then Marathon just uses that image to work. Okay? We can set the number of CPUs, the memory that we need, the number of instances of the container. Okay, and well, the video, I will upload it after the session. I will skip it. Well, I want to show you just one thing, okay? That. No, this one, no, a bit more. Okay, here. This is the real cluster. I have skipped the, the DNS and so. We are talking, in this case, about 20 CPUs and I don't remember if that were almost 70 gigas of RAM. We are talking about 5 nodes, exactly 5 nodes. You can see on the slaves activated, 5. This was on Spanish morning. That means New York people were sleeping. I have seen this grow up till 13 nodes, so that was crazy. So I will skip the video, 2 more slides, and we are done, okay? 3 minutes. Grab. Presentation. Okay, the conclusions. The project went live on first week of April of this year, less than 2 months ago. It was an absolute success. Today it's working. We have 38,000 sites right now, almost 90% very used. I have learned a lot about these new technologies, which I hope I have explained at least, not so bad. My bet, my personal bet, cloud plus containers is, you can be sure that you will be successful. That is the future. So please use it. Another point that I have learned, the flexibility of Drupal, in this case Drupal 7, is amazing. You know, I knew that Drupal is very flexible. We can use Drupal in almost any context, but I have learned another context and a very one that it's hard, but Drupal just works. It's amazing. And just my last slide, okay, I'm going to finish now. I recommend you to practice, okay? But practice, not just install Apache Mesos, put Marathon, and launch one container. No. If you have a bit of time, please go the long way. Go to Mordor walking, suffer, but when you get the ring just on the fire, you will have learned a lot, and you will be a better DevOps. Remember, lazy DevOps is better DevOps, is best DevOps. Thank you very much. Thank you. I have been a bit fast in the last part. I have skipped the demo because I need to be on time, you know. You know, 1 minute left. If you prefer, in 15 minutes we have the coffee, okay, coffee break, the same as yesterday, same door on the other building. So if you prefer have some questions now, please do, but we are off time, okay? You can tackle me on the building and just ask me. It's at your hand. Do you want to ask something here on public? No? Okay, then we are on time. Thank you again. That's my Twitter and my email if you need some way of contact. And please stop me on the building and ask me something, please. Thank you.